Welcome to lecture 2. So in this lecture we'll continue our topic on functions and we'll continue our topic on domain and range. So we already discussed that whenever we have a function, so the input is the domain, the output is the range. So when you have an ordered pair, for example, let's say we have an ordered pair of numbers here. So in this, which is domain and which is the range? So here all the first values that you see here, all the one that I'm writing in black, pointing in black, are all domains, and all the ones that I'm pointing here in red are range. So how would you write it? So we could write domain as the set of 1, 2, 3, 4, 5, and range as the set of 5, 15, 25, 35. So this is the domain and range of this given set. Now try to do the second one on your own. So pause the video right here and try to do the second one and try to find out which is the range and which is the domain. Now how do you find the domain if it's not mentioned as a set? Meaning that how do you find the domain of a function? So we define the function by an equation. Is first we identify the input values. Second, we identify any restrictions, this is important, of the input, and they exclude those values from the domain. So what are any restrictions is whenever you get, so when the domain value results in infinity, then we say that this is a restricted value. So these are the restricted values. Next, write the domain in interval form if possible, to make sure that we always write it in an interval form. So how would you write it in the interval form? So just like we discussed in chapter 2, the smallest number from the interval is written first, the largest number in the interval is written second, and we follow it with a comma, and you use parenthesis if the endpoint is not included, if you use brackets if the endpoint is included. So this is how we can do that. So let's try an example of this problem. So the first one is 5 minus 2x square. So for 5 minus 2x square, any value of x will give you a particularly good answer, which means that there are all set of values that are possible for this particular answer. So the domain here is the set of real numbers. The set of near numbers is from negative infinity to infinity. So this is the domain. Again, the second one again here. This is also for any x value, there is a possible range value that you can get for the function. Remember that you only restrict the values when a particular value results in infinity for the range. So in the range, if you get in infinity, we take out that domain value and we do not use that domain value. So that's the idea behind the domain values here. So try the same thing with the second problem here. Notice that this also will have the set of same real numbers. Next, how do you find it for a fraction? In a fraction, the restriction is always to make sure that the denominator is never equal to 0, because if the denominator becomes equal to 0, it means that will end up giving you infinity. So you don't want that to happen. So the domain condition, the restriction first that you want to write is 4x plus 2 is not equal to 0. So 4x is not equal to minus 2, x is not equal to minus 2 by 4. So 1's, 2's, so which is not equal to minus 1 by 2. So x, the value should not be equal to minus 1 by 2. So this is the condition that we have. So if you take up in this in terms of a number line, for example, let's say this is the number line, and on this number line we have 0 in the center here. So let's say 1, 2, 1, 2 and so on. So you're talking about minus 1 by 2. So let's consider that this is the value minus 1 by 2. Now this value should not be included, which means that this part is excluded. Everything before this is included. So we include everything before this and everything after this, but except for that value. How would you write this? Notice that on this end we have minus infinity, on this end we have plus infinity. So we can write from negative infinity until minus 1 by 2. Remember that we don't want to include minus 1 by 2. So write open interval union and then again minus 1 by 2 comma until infinity. So this is the domain for that problem. Or we can also write it as the set of real numbers minus the set of 1 minus 1 by 2. So R here basically represents the set of minus infinity to infinity. From that we are only taking out the value minus 1 by 2. So this is how we can find the domain for this particular problem. So let's so pause the video right here and try to do the same for this problem and try to find its domain. Next, let's do it for a root. So for a square root, the condition should be that the value inside the square root, so notice that under root ax plus b, the value inside the square root should always be greater than or equal to 0, because if it's less than 0, it becomes an imaginary number and imaginary numbers are not possible. So it has to be greater than or equal to 0. So how would you write this one here? So the condition here is that 4 minus 3x is always greater than or equal to 0. Now use the condition 4 minus 3x. So write plus 4 minus 4 on both sides. So greater than or equal to minus 4. So 4 and minus 4 gone. Minus 3x is greater than or equal to minus 4. Now divide minus on both sides. Then you will change the sign. So 3x becomes less than or equal to 4. So x less than or equal to 4 by 3. So this is the condition that we have to use. Write down this in the interval notation. So notice that how would you write that in the interval notation now? So you have a number line. So this is, let's say for example 4 by 3, and let's say this is the value 1. Then we have to include this value and everything that is before this. So that is towards negative infinity. So that is the value for x less than or equal to minus 4 by 3, and we are including minus 4 by 3 as well. Sorry, 4 by 3. Now, so how would you write this as the interval now? So from minus infinity comma 4 by 3 open interval. So remember that open interval here represents that we are including 4 by 3 as well, because it's less than or equal to. So this is the domain. So this is the domain. So try the same here. The condition will be so 5 plus 2x greater than or equal to 0. So pause the video and try to solve this problem. Next we have two conditions here. Notice that this is a domain that has two different conditions. There is a square root and there is a denominator. So the denominator is x minus 4 greater than, sorry, not equal to 0. And on the numerator you have x plus 4, which is also should be greater than or equal to 0. So x is not equal to 4 and x greater than or equal to negative 4. Now we have two conditions which we have to write it down. So write down the number line. Write down the number line. We have 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So the condition is x greater than or equal to minus 4. So that starts from minus 4 but including minus 4. So remember that we'll draw a dark spot for representing that it is included. We draw an open spot if it is excluded, right? We don't want that value. Now here x should not be equal to 4, which means that this should be excluded. So what does that mean here? It includes every value greater than or equal to negative 4 until 4, and after 4 again we can include the entire set. So how would you write this as a separate set? So we can write it as open interval negative 4, sorry, closed interval negative 4 comma 4 open interval union open interval 4 comma infinity. So what does that mean here? So here we are excluding 4. So we are removing the 4 from the set. So this is how you can see when you have complex two condition problems. So this is how we can use the interval notation to write down the answers. Next way is to find the domain and range from a graph. So one way to find domain and range from a graph is domain is represented by the set of x values, range is represented by the set of y values. So in this case, look for the x value and the y value for that particular axis. So from here to here. So here it's including the value, so this value here. So this coordinate, it includes it. Notice that the dark represents that it is included. So that is -3. So the domain here can be written as, so when it is a full dot, it means that is included. So on the x-axis that value is -3. On the y, on the other end, the x-axis is 2, but it is excluded because it's a circle. So this is the domain for the function that is mentioned. And the range, look at it in the y-axis. In the y-axis, we are starting from -5 from bottom to the top. Remember, when we write domain, we go from left to right. When you write range, we go from bottom to top. So in the bottom part, we have -5, which is included. So we have -5 comma. And on the range part, so you're going until a maximum value. The maximum value that can go is 4, so which is included. So 4 included. So this is how we could write the set of values that we do have. So this is how we write domain and range when you have it in a graph. So for a constant line, what is the domain? So the domain extends on all the axes, which means that, notice there is a straight line, the straight line mode configuration, which means that it extends from -infinity to infinity. The range here is one single value constant. So the range is C here. Whatever the constant is becomes the range. Next, for identity function, it's both -infinity to infinity and -infinity to infinity because it extends on both sides. Next, for absolute functions, notice that the domain extends on both sides, on this side as well, on this side as well. It includes all values. But range is starting at 0 and it's only going from 0. There is no negative values here. So that's why it's open interval, sorry, closed interval 0 comma infinity. So this is for an absolute value function. Next one is a quadratic function. In a quadratic function, again, domain is from -infinity to infinity. It extends on both sides on the x-axis. On the y-axis, it starts at 0 and it goes towards infinity. So open interval, sorry, closed interval 0 comma infinity for a quadratic function. Next one, for a cubic function, it extends on the right to left, so left to right, and also from bottom to top, so which means from -infinity to infinity for both domain and range for a cubic function. Next one, for a reciprocal function, here it does not include 0 for both the x-axis and the y values. So we have to eliminate 0, so we write -infinity to 0 open interval union 0 to infinity. Again, the range also the same, we do not want to include 0, so -infinity to 0 union 0 to infinity. So this is the domain and range for a reciprocal function. Next, for reciprocal squared, again domain will stay the same, it does not include 0 because notice that reciprocal squared is 1 by x square, so x square not equal to 0, so x should not be equal to 0. The same thing with reciprocal function here, 1 by x is not equal to 0, sorry, x not equal to 0. So 1 by x is the function, so we have x not equal to 0, so which we have to use for both domain and range. Here also the same reason, we use it for domain, but range here, because it's all positive values, there is always going to be only positive values from starting from 0 but does not include 0 to infinity. Next is the square root function. Square roots are x value, when you take square root x should always be greater than or equal to 0, so that is the domain, and root x value is always greater than or equal to 0, that's why 0 comma infinity again. The same for domain and range for a square root function. For a cube root is both -infinity to infinity and -infinity to infinity for both domain and range. So this is the domain and range for different values. Next one is a piecewise defined functions. Piecewise functions are a function where there is more than one formula that is used to define the output, and each formula will have its own domain, and the domain of the function is the union of all these smaller domains. So we are basically splitting it up into domains. One example of this is absolute value of x. Absolute value of x is plus x if x is greater than or equal to 0, minus x if x is less than 0. So this is the idea behind a piecewise function. So let's take how we write that down. So they're asking you, so a museum charges $10 per person for a guided tour with a group of 1 to 9 people, or a fixed $100 fee for a group of 10 or more people. So write a function relating the number of people here. So we can write that the cost C can be written as $10 times X if X is greater than or equal to, so between 1 to 9, so 1 less than or equal to X less than or equal to 9, and a fixed $100 fee, so $100 if X is greater than or equal to 10. So this is how we can write the function here. So here we are talking about the number of people, so let me write it as n. So 10 n, $10 times n, right, for until 1 less than or equal to X less than or equal to 9, and it's a fixed fee of $100 for any greater than 10. So this is how we can write it down. Now use the same principle here and try to solve this problem. So they're asking you to find the cost of 0.5 gigabytes of data and the cost of using 5 gigabytes of data. So if it is 0.5, you use the first principle, which is $25, and if the second principle were 5, which is g greater than or equal to 2, then substitute g equal to 5 into the second formula and write down the answer. So with that we end domain and range. So let's discuss the next topic, rate of change and behavior of graphs. So after this section, you should be able to find the average rate of change of a function. Second, you should be able to use a graph to determine the function whether it is increasing, decreasing or constant, and you should be able to locate the local maxima and local minima, and you should also be able to locate the absolute maximum and absolute minimum. So let's start with rate of change. So what is rate of change? So rate of change describes how an output quantity changes relative to the change in the input quantity. So the unit of rate of change are output units by the input units. So the average rate of change between two input values is the total change of the function values divided by the total change in the input values. So we call it delta y by delta x, which is f of x2 minus f of x1 by x2 minus x1. So the first thing we do is we calculate y2 minus y1. Second, we calculate x2 minus x1, and we calculate the ratio of those two values. So let's take an example of this and let's try to find the average rate of change. So what is given in the question? After picking up a friend who lives 10 miles away and living on a trip, Anna records her distance from home over time. So the values are shown in the table below. So they're asking us to find her average speed over the first 4 hours. Remember the term 4 hours. So this is 0 hours, first hour, second hour, third hour, fourth hour. So this is the one value that we want, and this is the second value. Here t represents x, d of t represents f of x. So remember the difference here, x represents d of x. Now what is going to be the rate of change, delta y by delta x, will be delta of d of t over delta t. So delta of d of t is going to be for the fourth hour. So we are considering for the first 4 hours. So for the fourth hour and the 0th hour. So for the fourth hour is 214 minus 10 over 4 minus 0. So 214 minus 10 by 4 minus 0. So this value will become 204 by 4. So which is going to become 51. So 51 miles per hour. So remember that this unit is miles and the x unit is hour. So 51 miles per hour. So the rate of change over the average speed over 4 hours is 51 miles per hour. So this is how we can calculate the average rate of change. Now in this, try this problem. Pause the video right here and try this problem. It's given there. They're asking us to find the average change between 2005 and 2010. So this is the two values that we have to take. So this is going to be y2. This is going to be x2. This is y1. Sorry. So this y here is x1, sorry, x2, and this is x1. This is y2. this value is y1. So pause the video right here and try to find the value of delta y by delta x. So which is y2 minus y1 by x2 minus x1. So pause the video right here and try to find the value of this problem. So how do you calculate the same sense from a graph? So you can also try to calculate the average rate of change from the graph based on the values that are given. So they are asking us to find between 2 and 5, x equal to 2 and x equal to 5. So for each of this, so x equal to 2, find the y value. So draw a straight line, a vertical line touching the intersection point and look for the y value of that line. So that value is 3, and for 5 the value is 7. Y is 7. So this is x1 y1, this is x2 y2. So delta y by delta x becomes 7 minus 3 by 5 minus 2. So this is 4 by 3. This is the rate of change that we have in the problem. So this is how we can find the values from the graph. Next, let's determine the concept of increasing and decreasing functions. So we say a function is increasing on an open interval if the value after it is greater than the value before it. So f of b becomes equal to f of a where b is greater than a. So which means that when you look at a function that's starting from the left here, if it goes upward, we call it an increasing function. If it goes downward, we call it a decreasing function. Again, it going upward, we call it an increasing function. So when is it increasing? So until a certain point. So the point where it changes from increasing to decreasing, we call it the inflection point. So we call it the inflection point. So the point where it changes from increasing to decreasing. So a function is said to be decreasing on an open interval if f of b is less than f of a when b is greater than a. So remember that the value is greater than a, but the functional value is going to be less than the previous value. So this is how we can determine this. So in this part here, which part we can determine based on increasing and decreasing. So notice that this part here is increasing, this part here is decreasing, and this part here is again increasing. So what we can do here, we can identify the intervals for each of these values. So we can say from minus 5 to minus 3. So notice that we are looking at it from the x concept here. So from negative infinity, so let me write it this way. From negative infinity to the value on the domain is minus 3. So negative infinity to minus 3, it is, so let me write it as negative 2 so that we don't get confused. So negative 2 excluding it. So this value is increasing. So it's an increasing function. From negative 2 to 1, it is decreasing. From 1 to infinity, again it's increasing. So this is how we can determine increasing and decreasing functions. So in the same way, now pause the video right here and try to solve these problems. So here they've already given you the values. So negative 8 is where it starts and negative 7 is where it ends. So what are the intervals, and try to find the intervals. Using the intervals, try to find which part is increasing, which part is decreasing, and write down the intervals for those values. So for example, I can give you the hint. It is increasing until here to here, and it is decreasing until here, and then again increasing again. So notice that there is no arrow. If there is an arrow, then we say minus infinity or plus infinity. But if there is no arrow and a strict point, only that value is to be taken. So note down these intervals and write down the increasing and decreasing part of these functions. So pause the video right here and try to solve this problem. So this is another example. Try this on your own. So pause the video right here and try to solve this problem. So you're always determining it from left to right. So remember that you're starting from the left side and you're always going towards the right side. So on the left side, you're going towards, from the left side, it's decreasing and then it's increasing again. So you're always looking from the left side. So always take it from the left side, never take it from the right side. So identity functions are increasing functions because they are only going from towards one side. In the same way, next, reciprocal functions are decreasing functions because they are always decreasing from left to right. When you take it from left side, it's decreasing. From left side, it's decreasing. So it's always a decreasing function on both intervals. And a square root function is always an increasing function, but on the interval 0 to infinity, because it starts from 0 and goes towards infinity. So this is how we can determine the common toolkit functions and their properties based on the functions that we have. So with this, we end the topic of rate of change and increasing and behavior of graphs.